It starts with a flush. Wastewater from 700,000 homes and businesses flows through sewers to the local sanitation plant.
Prior to recycling, the Orange County Sanitation District would treat the wastewater to a high level and discharge it into the ocean at a depth of 200 feet, 5 miles offshore.
The plant's methods are the same and include scraping to remove solid objects and 2 organic filtration processes that remove 90% of impurities. But instead of dumping treated sewage at sea, now they pump it to the Fountain Valley Treatment Plant, where scientists are trialing the new technology.
Each day we provide 265 million liters of highly treated wastewater for recycling. That's the same as if we were to fill up a large baseball stadium with water every day.
The scientists face a major challenge, turning liquid sewage into safe drinking water. The answer? 2 special filtration systems. First, fibers filter out particles bigger than 0.2 microns. 1/300th as thick as a human hair.
As you can see, there's all sorts of these tiny plastic straws, and these are the fibers, and there's actually over 15,000 of these fibers. And you can see they're very, very tiny, as if they're a tiny straw. And the process there, again, with this straw, is that if you were to pinch the bottom of the straw and suck on the straw, the water would go through the sides of the membrane and then out the top.
The water still teems with dangerous microbes. The next filter has to stop microscopic bugs but let water molecules through. The answer is an ingenious process called reverse osmosis.
We can see through this vessel what happens is the water would come in the end of the vessel and then come through, be forced under high pressure between the sheets of plastic, then be collected in this center tube and come out the end as purified water.
This is how it works. Water molecules are tiny compared to viruses and bacteria. If a water molecule was the size of a tennis ball, viruses would be as big as trucks and bacteria would be like buildings. A special plastic membrane peppered with microscopic holes exploits this size difference. It keeps the bad guys out, but lets water molecules pass. As a final precaution, ultraviolet rays zap the purified water, exterminating any rogue bugs by scrambling their DNA.
The water that's produced here is extremely safe. We pull samples on daily, weekly basis. We actually have over 2,000 compounds that we have to test for as a part of our discharge permit to satisfy the regulators that this water indeed is safe. This water is as pure a water as you're going to find. In fact, in a lot of cases, it's purer than even mountain spring water. Boy, that water tastes great. That's the best tasting water I've had in a long time.
Marcus enjoys his own product, but he has a dilemma. At this stage, the average person would say it's tasteless. To acquire a pleasing taste, the water travels 13 miles inland to be piped deep underground. There, it soaks up the natural minerals that make water taste like water. Marcus and his team are working on easier ways to add flavor. In future cities like Ecopolis, that would mean recycled water could be piped from the plant straight into people's homes. Today, 145,000 Orange County families already drink and wash with water recycled from sewage. That system uses just half the energy it takes to pump fresh water from the north.
I think right now we do a very, very poor job individually and collectively in our use of water. It's a very, very precious resource, it's a limited resource, and we have to do everything that we can in the future to minimize its use.
But how much carbon will recycling water save? And will it be beaten by this revolutionary dung-based power source? Top scientist Dan Kamen is on a mission, assessing 4 new technologies that could slash carbon emissions in Ecopolis, megacity of the future. But he can only choose one. The carbon counters have analyzed how much carbon would be saved if Ecopolis recycled all its sewage. The result is a surprise. the megacity's carbon footprint would shrink only 12%, a fraction of the savings from urban farming, but more than acoustic refrigeration.
It still requires a lot of energy to run the pumps and to run the generators, and that means that just keeping the water quality the same is going to require a larger and larger energy and hence carbon footprint.
Cameron has time to make up his mind. And before he votes, there's one final idea to explore.